Without this, we cannot learn, we cannot memorize anything. Now, this is another sub-region within that hippocampus, and called dentate gyros. It's very interesting, this sub-region. It's the only, well, almost the only region in the brain in which new neurons are being formed on a daily basis. Not too many, but those that are made are important. Let's go a little bit deeper into that region. And immediately you will start to see the electrical activity that characterizes the function of cells in the brain, of the neurons in the brain. Okay? Now we're zooming in, and eventually we'll get to the organelle in these cells that is the most interesting and most important for learning. Is one amongst the first two being destroyed in Alzheimer's. Okay, now we zoom in into the cell. These are the dendrites. They receive signals. This is the soma, I mean the cell body. This is the axon. From here it shoots messages forward. As we get closer to the cell, you start to see these structures. Okay, these are called dendritic spines. We'll get closer and you will see how these structures are dynamic. They move. Okay, they move like small worms. Okay, so this purple cell is cell A. This green cell is cell B. Now, these structures, these spines, are the connecting structures between one cell and another. Okay? Now you will see that these structures form a contact with the other neuron, and it actually forms a synapse. Perhaps you heard this term, synapse. This is where communication occurs between the neurons in the brain. Okay? This is the most important thing. Now, what happens when we run? Okay, that was shown in animals. When we run and we look at the slice of the brain that we just saw, that the hippocampus, okay, and we look for how many new cells are being born, you can actually, let's look at it here. All those black spots are new cells in the brain, okay? Now, take a look at the hippocampus of a mouse that ran, that spent many days running. And mice like to run. You put the running wheel in the cage of the mouse, they run kilometers. You know, voluntarily. Okay? Put a treadmill in anyone's living room, immediately it becomes something to put clothes on. That's amazing. You don't know what to do with these things. And it's so heavy. Can't move it. Okay. Anyway, in the brain of the mice, you can immediately see how many more new neurons are being formed. Okay? So that's insane. This physiological thing that we can do increases the number of neurons in a critically important subregion of our brain. We don't do that. Okay? That's one. Second, you remember those dendritic spines that I just showed you in the movie? Here you can see that when we are born, we don't have too many of those. Okay? That's actually done on monkeys. However, as monkeys and us age, the number of these spines increases. Okay? That's the result of experiences that we undergo. And as we age, the number of these synapses goes down. And in Alzheimer's, even more so than that. Okay, here you can see an even nicer picture of these dendritic spines. So remember, these are the structures in which neurons communicate with one another. Without that communication, we cannot function. Okay. Now, I want to show you that a change in the number of these spines is both rapid and long-term. Here you can see a graph. It seems complicated, but it's okay. This axis shows you the number of these structures, okay? And the red shows you an animal that has been trained. In this example, it's a motor function, okay? Imagine you learn how to ride a bicycle, okay? You can see that there is an immediate, okay, increase. It's within 1 hour. in the number of these spines. And then you can see a decrease, which is fine, but still it shows that it's more than an animal that doesn't learn, okay? Doesn't learn the task. So this change is both rapid and long-term. Now, having said that, most of the people, well, some of the people can't run, okay? That's a given, we know that. But the fact is that most of the people don't do that because they just don't want to run or to be engaged in a cognitively challenging environment, okay? So let me just make some order. Physical exercise or aerobic physical exercise increases the number of newly formed neurons in the hippocampus, okay, in the region critical for learning. And engaging in a enriched environment, that is an environment in which we absorb information through many channels, smell, vision, auditory, touch, that increases the number of those connections that I showed you between the neurons, the spines. A combination of these two activities, physical activity on one hand and enriched environment on the other hand, generates a synergistic effect, okay? So, as I told you, most of the people don't do that. And that despite of the fact, now you should know that, despite of the fact that 1 in 3 individuals above the age of 65 fall each year. Now, the number of people that fall at these ages is higher in people that did not engage in physical exercise throughout their life. Okay? Now, here's another fact you should know. In most individuals that fall at these ages, immediately following their fall, which of course is accompanied with a hip fracture or a hand fracture or a leg fracture, their cognitive capacity declines rapidly. This is almost a sure sign. If you know someone fell, hope nobody here fell. If you know someone fell, their cognitive capacity will go down. It's almost a given. Okay? So, my take-home message is, we are doing the best we can to come up with innovative ideas to treat Alzheimer's. And we can really come up with we have good ideas. Not talking about just about myself. Other people, really smart people, put their lives into developing treatments for Alzheimer's and other diseases. But none of these ideas can or should replace activities such as physical exercise and activity and engaging in a stimulating environment. Okay? So, with that, I would like, first of all, to thank you for coming and for this event. This is my lab at Bar-Ilan University, the Ganda Brain Research Center. These are the sources that fund our work that we enjoy very much doing. And with that, I would like to end with a happy aging. Thank you. I guess there is a question session now.
Thanks, Eitan. Just remain up here with us. I'd like to now call to the stage Dr. Alexa Gottdiener, Chief of Medicine at Englewood Hospital and Medical Center, and Dr. Gary Allweiss, who will join Dr. Okun for a question and answer. And I know that Dr. Gottdiener will field the questions. So thank you again, Eitan.
first question.
Generally, when we hear about vaccines, we're assuming that this is something that will be given to the general population. And still you were emphasizing the search for, it seems that you would emphasize vaccinating only those who are expected to come down with the disease. Why is that different here in this case?
That's a good question, which means that I didn't explain it already. There are two stages, I guess. One is we need to develop a vaccine in a way that it will be acceptable by those that allow vaccines or other drugs to be marketed, etc. So we have a strategy for that. And our strategy is to prove that efficacy of this drug, of this vaccine, as early as possible. And the population that we believe is the best to do that is Down syndrome. However, down the road, eventually, if this vaccine will, or any other vaccine, that's fine, you know. I don't care. Anyone who develops anything, that's fine, as long as it's efficient. Should be administered to the entire population. For the reason that the majority of people with Alzheimer's, we have no idea that they will have Alzheimer's, or when, or at what severity. Okay?
Yes, hi. Two things. One, about 2 years ago, I read something about green tea, and there's something in green tea that can actually start to reduce the amyloid proteins, the protein in the brain. I don't know if you're familiar with that. And secondly, just recently I saw something within the last several months that there was an injection that could actually start to reverse the dementia or the Alzheimer's